Let's try the following thought experiment. Higher order derivatives. Well, what do we mean by that? Well, if you take the derivative of a derivative, what happens? Well, let's go back. What do we mean by the derivative in the first place? The derivative is the slope producing function, but it's a function, right? So if we start out with a function like this and we take its derivative, we should be able to get another function, right? And we call that function f prime of x. So in this case, I have my function f of x equals x cubed minus x squared plus 2x minus 2. And so if I take my derivative right here, going term by term, my derivative will be 3x squared as the derivative of the first term, minus 2x as the derivative of my second term, plus 2 times 1 as the derivative of my third term, minus 0 as my last term, but I'm going to write that in the simplified form, 3x squared minus 2x plus 2. All right, so this is my function f prime of x in that simplified form. But it's a function. And just like other functions, we could take the derivative of it. And so let's do that. Here's some notation for you. If we take a second derivative, instead of calling it f prime, we call it f double prime. 2 hash marks up here indicate that it's a second derivative. We also, using the dy dx notation, would write it as it looks like d squared y over dx squared. We read this as the second derivative of y with respect to x. So, what does that mean for us? Well, if we're taking the derivative, f double prime of x, in my example, is the derivative of our first derivative. So we're going to take 3 times the x squared derivative as 2x minus 2 times the derivative of x, that's just 1, plus 0 as my derivative, my constant 2. So f double prime of x is going to be equal to 6x minus 2 in this case. Not so bad, you think? Well, yeah, you're right. I mean, in this case, the only thing that we have to recognize is that this notation indicates that once you've taken your derivative, take your derivative again. We could keep going. What's the derivative of our derivative? Well, we use what's called a higher order derivative. Now, higher order derivative, if we're talking about a third derivative, in this case, our third derivative, f triple prime of x, we also write it as looks like d cubed y over dx squared. We read it, the third derivative of y with respect to x. And in our case, for our example right here, f triple prime of x is equal to 6 times the derivative of x minus the derivative of 2, which is 0. So our third derivative is just equal to the constant 6. We could keep going like that, but after we end up with the third derivative, we just start putting in a number here. We don't use the prime notation anymore. So if I'm looking for my fourth derivative, I would take the derivative of my third derivative function. In this case, I will say this. We will get f, the fourth derivative of x, that is the derivative of the third derivative. In this case, that's going to equal 0. Now, we say that we can continue taking derivatives until we reach a derivative that's equal to 0. And in this case, yeah, our derivative is 0, so we would stop. There is no fifth derivative or sixth derivative or onward. But for any nth derivative over 3, we write it this way. The nth derivative, we put a little n in parentheses up here for x, or we write the nth derivative of y with respect to x. As long as we're talking about those integers being in terms of integers, right? We're whole numbers greater than or equal to 1. That's our derivative. First, second, third, fourth, and higher derivatives.